Best part of having fun!
We're about to experience a historic astronomical event. This is something that you will want to tell your grandkids about when we're living on Mars in 70 years.
Right! But you won't be able to see your grandkids if you don't follow a few simple safety precautions. First of all, don't look at the sun with your naked eye. That's a recipe for disaster.
When looking up at the sun, use your approved Eclipse viewing glasses.
It's easy! Whoa, those are dark. Yes, don't try to walk around the building with these.
Remember, here in Marietta, we don't have complete totality, so there is no safe time to look at the eclipse without glasses.
Hey, Dragon, get away from my son. Say hello to my little friend!
Whoa there. You'll shoot an eye out with that thing.
You'll shoot your eye out, kid.
The sun isn't being eaten by an ancient monster.
Lots of cultures have thought that the sun was being eaten by a monster. The Vietnamese said it was a giant frog, while in Siberia, they thought it was a bear.
True. Ancient Hindu mythology says that the decapitated demon, Rahu, chases the sun and eventually catches it, swallows it, and it comes back out.
And the Vikings believed that a wolf named Skull would steal the sun. So what's the real explanation?
Even better, let's get Mr. Hoover to explain it.
Ground control to Major Tom.
Did someone say my name? Hi there, my name's Mr. Hoover. You might recognize me from astronomy class, biology class, or everyone's favorite lunch duty in the 300 hall. Please pardon how I'm dressed at the moment. I was working on my space shuttle to go up in space so I can go watch the eclipse in space. So you guys had some questions about solar eclipses, is this true?
Yes, very true.
Alrighty. Well, let me do a couple demonstrations and then we'll actually go to the classroom in a few minutes, but let me get a couple of you to volunteer here. Let me get some props. Hang on one second. So we have the Earth here. I'm going to use a smaller Earth. Obviously, this is not full-size Earth. We have this little ping pong ball, which is going to be our moon. And then we have this flashlight here. This is going to be our sun. All right. Before we continue, I'd like to mention a couple things about safety. Our lovely MCs here mentioned safety already, but I just want to make sure you're aware of what kind of glasses we should be using. So when you look at your glasses, you want to make sure there is an ISO number on here. This says 12312-2. There's different certifications. You want to make sure it says ISO 12312-2. There's also a -1. The -1 means you can view the sun, but you can only view it for a few minutes at a time. The -2 means you can view it throughout the entire eclipse. The eclipse here is going to last from 1:05 p.m. to 4:01 p.m. So if you're lucky enough to go outside, come on outside and watch. My astronomy kids and I, we're going to be partying outside all day. Also, I've had a few questions about, is it okay to wear masks like welding mask? You should not wear a welding mask or sunglasses because it will affect your eyes. If you do want to wear a welding mask, you have to make sure you have a number of 12 for the welding lens. If it's below that, it won't filter out the UV radiation, which is what cooks your eyes. We want to make sure everyone stays safe during this time. Okay, so we're going to use our MCs here. I've got MC Moon, I've got MC Earth, and I've got MC Sunlight. So we're having a total solar eclipse. Total solar eclipse, they seem very rare, but they actually are about once every 18 months. The issue is from the Earth, we only have about 0.5% of the Earth actually covered during a total solar eclipse each time. And we haven't had one that's been a total solar eclipse in Atlanta since 1984. We have had a few other solar eclipses, the latest one being 1991, I do believe was one of the last ones. But it's going to be a big deal. I've been excited about this solar eclipse since about 2004. So I've been looking forward to it. The next solar eclipse we're going to have that's a total is in 2024, so you want to make sure you get out and look at this one while you can. So during a solar eclipse, there is an alignment between the moon, right there, the Earth, right there, and our sun. So the sun's going to be over here though.
Okay.
So if we see our sunlight, you can see the light shining on the dark side of the moon, and there's no light on the near side of the moon. Over here, here's the Earth. You'll notice that the sunlight is pointing on the day side, which is why the sun's out during the day. Duh. So what we see here is there's an alignment between the three of them, and that's a total solar eclipse. In a few minutes, we're going to go back to the classroom. I'm going to talk to you more about why this occurs. But this doesn't happen every month. You might think it might happen every month when the moon is new. Right now the moon is new because we don't see any light on the near side. It's all on the dark side. The reason this doesn't happen though is because the moon's tilt going around the Earth is 5 degrees off the Earth's tilt going around the sun. So what happens here is my MC Moon, she's going to move her hand around the Earth, and it's going to be a little angled. And then my Earth, he's going to move around the sun, and they're going to move together. So MC Moon is going to move around the Earth, and MC Earth is going to move around the sun. My sun's going to stay still. So let's see it. Let's see you guys move. Oh, keep going. You got to go all the way around the sun.
Oh, hey, I've got one. I like that.
Alrighty, as you can see, that was a hot mess. So what we're going to do here is I'm going to actually show you a diagram of it, the actual movement, because obviously this isn't going to work. So we're going to go to the classroom. I'll be right back. So we're back in the classroom now, and after that silly little escapade in the gym, we're going to now figure out how eclipses work. I kind of want to open this to questions from the audience here to see what kind of questions you guys have about eclipses. So are there any questions?
Yeah, so why don't we have eclipses every month?
That is a great question. Okay, so the reason we don't have eclipses every month, I tried to explain this in the gym, but here this will make a little bit more sense. Here you can see that we have the sun, we've got the moon, and then we have the Earth. In this picture here, we have the shadow of the moon on the Earth. Well, the moon, it just so happens that we live in a time right now where the moon is actually right about the same size as the sun in the sky. That's not always the case. We'll talk more about that in a few minutes. But let's just take a look at the moon's orbit. So we can see here, this path right here, this is the Earth's orbit going around, it's supposed to be going around the sun. This path right here, this is the moon's orbit going around the Earth. So you can see here that this tilt here, there's a 5-degree difference. And because of that 5-degree difference, the moon does not always line up with the Earth. It takes 29.5 days for the moon to go through a cycle of phases, which means it takes 29.5 days for the moon to orbit around the Earth once. So during that time period, the moon only aligns up with the Earth and the sun twice a month. Now, just because it lines up with the Earth and sun, with the Earth, that does not mean that the Earth is aligned with the sun. It only happens about twice per year, 2 times per year, where the Earth, moon, and sun will align up somehow, and when that happens, that's when you have eclipses. When they align up, you can see that the moon has to cross the sun's plane here. When that happens, that place where they align up, right here and here, that's called a node. There's 2 nodes. And when you have those 2 nodes, that's when you have eclipses. Okay? So we don't have it every month because they're not aligned. Other questions?
What kind of eclipses are there?
That's a great question too. There's actually 2 kinds of eclipses. You have solar eclipses and lunar eclipses. Now this one's going to be a solar eclipse, and it's a total solar eclipse. There's also lunar eclipses. So solar eclipses don't last very long. A typical solar eclipse, when it's a total solar eclipse, it'll last between 2 and 7 minutes for the totality. That's when the moon will completely cover the sun. Lunar eclipses will actually last for hours and hours and hours. And when that happens, the reason that happens is because the Earth will block the moon, and I'll show a picture of that in just a minute. Let's go ahead and watch a video clip here so we can actually see the path of the moon going around the Earth, and we can see how they only align at 2 nodes, okay? So let's take a look. So in that video you just saw, you can see here that the moon is not aligned with the Earth. Oops, sorry about that. So the moon is not aligned with the Earth, and that's because of the 5-degree difference. So here are those nodes that we were looking at. So here's the alignment of the nodes right here. So right there and there, that's when the moon actually crosses the sun's path. So those are the 2 places where you can actually have an eclipse for the year. Okay, so talking about those eclipses, the lunar and solar eclipses, we have to mention 2 words, 2 vocabulary words. I like to call them essential vocabulary words. So you got to know about an umbra and a penumbra. So if you can see this, we have the sun, we have the Earth, and then here's the moon. So when the moon is behind the sun, when the moon is behind the Earth, when the moon is behind the Earth, it is completely in the shadow here. A complete shadow is called an umbra. Where over here on the side, you've got, it's called a penumbra, which is a partial shadow. When the moon or Earth are over here in the penumbra, that's when you have a partial solar eclipse. You can have a partial lunar eclipse, or you can have a partial solar eclipse. When the moon or the Earth are in the umbra, that's when you have a total solar eclipse or a total lunar eclipse. The issue is sometimes the moon and Earth aren't close enough together because the moon orbits around the Earth, and another word we have to know, it's called an ellipse. So sometimes the moon is closer to the Earth, sometimes it's farther away. So when it's closer to the Earth, that's when you have totality. When it's further away, that's when you have, it's called an annular eclipse, and that's when the sun looks like a donut, actually. Now I'm hungry. So let's take a little video clip.
Blinded by the light, wrapped up like a douche, another runner in the night. Blinded by the light, wrapped up like a douche, another runner in the night. Blinded by the light, wrapped up like a madman drums, bombers, engines in the summer with a teenage diplomat. In the dumps with the monks at the end.
Let's take another question.
Why are solar eclipses so short?
Well, like I said before, solar eclipses, they only last between 2 and 7 minutes for totality whenever you have total solar eclipse. The reason that is because the moon and the sun, right now, we live in a time, it's a perfect time because the moon and sun are about equal distance, they look the same in the sky. They're not actually the same size, but they look the same size. The sun is actually about 400 times larger than the moon, but the sun is also about 400 times farther away from the moon than the Earth is. So just because of that, they look like they're about the same size. So we live in a time where the moon perfectly covers the sun. The issue is it barely covers the sun. And the moon is moving 1,000 miles per hour across the surface of the Earth during a total solar eclipse. So when it does that, it doesn't cover the sun for very long. In fact, I mentioned this before, only 0.5% of the entire landmass on the Earth is covered during a total solar eclipse. The shadow that we'll see in just a minute in the video we watch, you'll see it move quickly across the Earth. You'll see the Earth rotating at about 1,000 miles per hour, and the moon is actually moving about 2,000 miles per hour. But the shadow actually only covers about 70 miles across. That's why if you go up to North Georgia, you'll see totality, but if you stay down here, we're only going to see about 90% coverage. I think this is going to be the last slide. Okay, last question. So, are there any other questions?
Yeah, so what should we expect to see?
Okay, so when we look at the eclipse, we're going to see about 90% coverage. And this is going to be the first time this has happened going coast to coast. This is a coast-to-coast eclipse of the United States. Hasn't happened in 99 years. I'm super excited, as you can tell. Our next eclipse, it's not going to be till 2024, and it's only going to cover the Midwest. So again, if you can, you want to get out there and see this big bad boy because it's going to be awesome.
I'll see you on the dark side of the moon.